Hey listeners, welcome to Radio Craftinity with another episode of Machine Learning Made Known. My name is Andrew and I'll be your co-host.
And I'm Megan, I'm the other co-host.
Today we're going to be learning about machine learning on mobile devices. We'll be interviewing our guest, Konrad Muchowicz, who is an iOS developer and machine learning developer at Untitled Kingdom.
So a little bit of background information on Konrad before we start. He's been coding for about 8 years. He's worked mostly on mobile and IoT solutions based on Bluetooth Low Energy. Currently at Untitled Kingdom, he's focused primarily on machine learning in the mobile development context. Hey, Konrad.
Hello, everyone.
So let's talk about mobile and machine learning. So how would I go about deploying a machine learning powered app on a smartphone?
Well, everything depends what's the problem you're trying to solve. In many cases, you don't have to train or deploy machine learning yourself. Sometimes using fully managed machine learning services, it's the quick and easy option. There's a growing number of companies that provide machine learning services tailored for specific purposes, such as speech recognition, text analysis, or image classification. However, you don't get access to their models directly. That's their secret. But you can use these models through an API. In case you need a model for a more specific use case based on your dataset, better option would be using hosted machine learning in the cloud. This solution still does not require that you have the expertise to train your machine learning models. All you need to do is simply upload your data, choose the kind of model you want to use, and let the machine learning service take care of the details. If you are really serious about your machine learning and want to have full control, you should either do the training in the cloud or your own machines. Trained models could be used for inference on server or on device. Both approaches have its advantages and drawbacks.
Could you give me some examples of app types for which this approach wouldn't suffice?
Sure, basically, it's all apps that tackle more specific tasks, and all apps that need to provide machine learning-based features offline and quickly. Another thing is that sometimes you would not want the user data to leave their devices, mostly due to privacy concerns. So, for instance, the popular Prisma app that allows you to transfer styles of famous artists into your photos and videos. I'm not sure whether there's any company that provides service like that through their API. Well, but I might be wrong. But the point is, if your data is unique in some sense, or existing solutions are not satisfactory, you would really benefit from training your own model, well, just for better results. For example, Snapchat needs to detect facial features in order to apply their fancy filters, and it needs to work quick. By the way, now it's possible with Apple Vision Framework. It's a part of CoreML, but we'll probably get into that later.
Yeah, it's because of paying per request, I think that usually makes people want to switch to a different approach.
I wouldn't say that's the main reason, but it would definitely affect the ability to scale. Well, if you have to pay per each request, right?
Yeah.
So is there a particular reason why the providers don't offer sophisticated machine learning models?
They cannot do, and it's getting better and better, but it's hard to offer generic solutions, especially tailored for specific needs. Maybe it's better to experiment with some different architectures and approaches for the better results.
Okay, so when it comes to popularity, what do you think will be the percentage of the most common apps that use this approach?
In my opinion, if you can afford it, and if you have skillful people on board, I would say that's the best way to go. And I think that the most companies do it. And it depends whether machine learning features are just an AI enrichment or the machine learning is the core feature of your app. So I would say that the most apps that have the machine learning features as the core, they use this approach. Provided you own your model, you can use it on the server side or perform inference directly on a device.
Without performing inference directly on the device. How would you do that?
Okay, so maybe let's talk about iOS. Well, up until iOS 11, developers were kind of limited to use some third-party frameworks or these provided by Apple. So that would be BNNS or so-called bananas. And it's basic neural network subroutines, and it's a part of the Accelerate framework. And that's the collection of math functions that take the full advantage of the CPU. The other option would be using metal performance shaders, and that's the library optimized to run on a GPU instead of a CPU. But since last Apple Developer Conference, there's something more. It's CoreML, and it does not reflect common understanding of a machine learning framework, because you can't use it to train models based on data, but it's still fine. Training on a device, it's not something you would want to do anyway. Its only purpose is to perform inference on a device, mainly in machine learning tasks like classification and regression. So, in order to get it working, you need a trained model in Apple-specific open ML model file format. It does contain all the information like the model architecture, weight and biases, class labels, and so on. There's also a cool Python package called CoreML Tools, and it can be used to convert existing models from popular machine learning tools, including Keras, Caffe, scikit-learn, into this Apple format and make predictions within your app.
How would one go about converting a Caffe model into a CoreML model? What would be the typical difficulties?
Can't really say about difficulties because they made it really easy process. All you need to do is to convert your model using the CoreML converter that corresponds to your model third-party tool. For example, if your model was created using Caffe, you just pass the Caffe model to the right converted method. Once it's done, you can drag and drop model file directly into your Xcode project. And depending on your model, you might need to update inputs, outputs, labels, declare the image names, types, formats, and so on. But the conversion tools are bundled with documentation, as the options may vary, so it's not that hard. I would also recommend doing a quick checkup whether both models behave the same way on the same test set. And the reason for that is the CoreML tools optimization. There is a chance something might go wrong along the way.
What else is it capable of?
Well, it comes with new tools like the Vision framework and some new natural language processing tools. Both play really nicely with CoreML, allowing you to pre-process your data before being fed into the model. So the kind of jobs Vision can perform are that would be finding faces within an image, or finding detailed facial features such as location of the eyes and the mouth, or maybe the shape of your head. It also allows you to transform the two images so their content is aligned. So that's kind of useful for stitching together photos. You can track movement of objects in a video, detect the regions of the image that contain text. You can also detect and recognize barcodes.
Does it use a CPU or a GPU?
So it's optimized to run fast and efficiently on your phone. This means that you don't have to worry about whether it runs on the GPU or CPU. Apple actively switches between the CPU and the GPU based on how computation and memory heavy the task. That's great, but you can't force CoreML to run on the GPU even if you really want to.
Okay, so could you tell us what else you're working on, particularly at Untitled Kingdom?
Sure. So here at Untitled Kingdom, we use machine learning for speech recognition in order to transcribe videos into scripts. We also work on a few IoT femtech products with quite large amounts of data. So we are trying to apply machine learning for recognizing patterns and gaining some insight into it. Apart from that, we are playing with latest mobile frameworks, creating some cool in-house prototypes.
All right, that sounds pretty nice. So that's all we have time for today. Thanks, Konrad, for joining us here.
Thanks very much.
Yeah.
And we hope to see you next time, our dear listeners. Bye.
Bye.
Bye.